Good morning, guys. I hope you're all fine today, healthy. Today, as you see, we'll start a new chapter, a totally new one. Since in the first 3 weeks, we were discussing some introductory kind of issues about 3D printing and additive manufacturing, but this time we'll be jumping into an additive manufacturing methods. This first one we are going to cover is called as extrusion-based systems. And here you see one of the most popular extrusion-based systems is filament fabrication. And today, I first plan to actually go through this kind of 3D printer, show you some fundamentals, and start a printing process, and then continue with the slides. But I had a little problem. One of my nozzles was empty, but now in a moment I will make it work in real time. So right now it's trying to actually load material into this nozzle, and I think it's better I start from the whole design. This is a 3-axis type of fused filament fabrication system, and this is our table. It moves in Z direction, and the thing is that it has a heater underneath. Actually, it heats these tables so that your extruded materials will be actually stick on it. Otherwise, in the upcoming layers, you will have problems. So sticking is quite important, especially in FDM type of systems. Your first layer should properly stick here. Yep.
Can you please close the your ekranınızı kapatıp hocam kendi kameranızı büyütme şansınız var mı? Ben büyütemedim ama.
Sure. How's now?
Hocam pin video yaparsanız hocayı büyüyor aslında ekran ama.
Right now I don't share anything, so it should be.
Teşekkürler hocam.
Okay. Let's also pin myself. Yes. So right now I am fixing a problem with material, but I think it's almost fine. So I can confirm and get these things out. Yes. Now I was telling you the fundamental axis. As I said, this is the bed, and this is made of glass. For this type of printer, it's just like glass, as you see. And the thing is that we have some heaters underneath. Right now, it's not heated, so I can easily touch it. But once we start the printing process, it will start heating the metal part underneath this glass, so that the first layer will easily be stick to this table. We close these. Okay, as I mentioned, this one is moving in Z-axis, and at the beginning of the operation, this table will be, in a moment, you will see that at this height. Since it will be the first layer, once the first layer is done, it will move a little bit, and as it will continue moving downwards as you're actually part being printed. Let's say that if you are printing this one, initially we will have the base, and then once it goes downwards, we will be printing the upper regions. And I want to focus more on this actually head. You see, I think this one has 2 nozzles. We have a nozzle on the left-hand side, another one on the right-hand side. You see that there are different letters. We have a special one, CC 0.6. 0.6 means that the nozzle diameter is 0.6 millimeter. The right one has a diameter of 0.4, which is most common diameter for fused filament fabrication systems. And I can show you another nozzle here. This is actually a very flexible system. Ultimaker printers usually use such nozzles, and you can easily remove it by pressing this thing, actually plug it in and then remove. So why do we actually have such many nozzles? They want to actually give you some freedom. You may print some difficult materials. If that's the case, then you need to change your material. For instance, this is CC 0.6. We use it for our research purposes. We have a special filament at the back side, and it has some little carbon fibers inside, so it's quite abrasive. So if you use the conventional nozzles, their nozzles will be worn out, and worn out maybe in a few days. But if you use a very special one, a coated nozzle, then it will be able to withstand to the wear properties of the carbon fibers, and you can easily extrude some plastics with little carbon fibers inside. But the other one is a conventional one, and this is also one of the conventional, but the difference is that this time the diameter is 0.25. What it means is that if you want to produce a very small part having many little features, then you may use a nozzle with a smaller diameter. But as I mentioned, 0.4 is fine for most of the time, and you can print any product with it. So that means actually your minimum feature size should be 0.4 or more than that. If you want to produce, let's say, a feature having a size of 0.2 millimeter, then you will not be able to do that with this specific nozzle. Maybe you may try 0.25. And let me focus on the details of this one. This is actually the nozzle, the tip of the nozzle. I can show you. I'm not sure whether you see there's a little hole at the tip. And this is our actually heating block. This rectangular part. We have connectors here, as you see. These are kind of we have a resistance there. So current is flowing into these resistors and heating that heating plug. And then we have another cables. The other cables are for measuring the temperature. Since we want to control this temperature at a specific value, usually around 200 temperatures for these type of materials. And this is done with the help of the heater and reader. This is kind of a sensor. It's reading the temperature. It's a kind of a thermocouple. And we have a little board here is transferring these to the signals to the main board of the extruder head. And on the other hand, we also have some fans around. We have one fan on the right hand side, one fan on the left hand side, and one at the front of this extruder head. The aim of these fans are actually to decrease the temperature of the material which has been just extruded. Since during the extrusion, the temperature is around 200 degrees Celsius here, but once the material is extruded, its temperature should be decreased as soon as possible. Since if the temperature is high, then it will not be able to retain its shape and may go over the table, and you will not obtain actually the dimensional accuracy you want. So that's why cooling the fans are highly important. And then these are the cables. This is for electrical connection. We have, and as I mentioned, a kind of a controller at the back side. And this is for filaments left hand side. And this is feeding the right extruder. And we have some at the back side. I don't know, yes, you see that it's a stepper motor is responsible for moving our printer on X or Y. I should check whether it's an X or Y motor, but it doesn't matter. These are responsible for the motion on this XY plane. And you can clearly see that we are transferring the motion from the stepper motors via such belts, such timing belts. They are not expensive and not complicated. And for the Z-axis, we use a kind of a screw here. In a moment, you will see that it will simply return and move this bat actually upwards. And we have a user interface, a very simple user interface. Right now, it gives an error warning, but it doesn't matter. Let me ignore this one. So this is our main window. We can do printing. we can start printing process, change material, change the extruder, or check our system whether it has any problems, or we may want to do some modifications on the printer. In a moment, I will import a design into, let's say, Cura. You have already know some information about Cura. We will do some settings there and try to print a part. And I didn't show you, but let me show you some example material. At the back side of this actually printer, there are such spools, and these are filaments, and we use such filaments during the fused filament fabrication system. As the name implies, this is fusing the filaments, and with the help of them, it's fabricating parts. That's why it's called fused filament fabrication. And sometimes we may use special materials, special filaments, like having carbon fibers or some water soluble, let's say, filaments. But right now I don't have a special one. I will be using polylactic acid, which is the most popular type of material in fused filament fabrication. Is abbreviated as PLA. Any questions, guys, before I open the Cura and start some printing?
Hocam,
Yeah.
bu makinenin fiyatı ne kadar?
I don't remember actually, but it should be around 5,000 euros.
Tamam, teşekkür ederim.
You're welcome. But I got it with the help of some project funds, not obviously myself. Any other questions, guys?
Hocam zeminin cam olmasının özel bir sebebi var mı?
No, we will talk about that. It's just for making it easily stick. And once you increase the temperature, heat will easily flow into that glass, and you can easily stick your part to the table. But in some cases, there are also some printers which are not using a heated bed. Instead, what they do, they have such special tapes. They tape the table, and once you extrude material on this tape, on this special tape, it will be sticked. So instead of heating your base plate, you may also use such solutions. It's not a must. Actually, it's not a must for PLA material, but if you are using some, probably most of you, some of you know, if you are using, for instance, ABS material, it's actually a must to heat the table. Otherwise, you'll not be able to keep your part in position. It will not be sticked, and it will move, it will oscillate, and you will not have a proper product. So for most of the time, we prefer to heat this table. Any other questions?
Hocam buradaki beltin amacı tam olarak neydi?
Transfer the motion. So since we have a stepper motor here, it's rotating, it's obviously a motor. So we are translating this rotational motion into a linear motion.
Tamam, sağ olun.
I may show you the top side. Let me table in a moment and show you. I think it's better the top side and the back side. Yeah, this is the top side, as you see, and we have these bells, and as I mentioned, they are transferring this rotational motion to linear motion. Top side, and at the back side, we have these spools of material. Now I'm going to use this gray one. As I mentioned, this one has some carbon fibers inside, and it needs to have some special settings, so I'm not going to spend time on it, but I will be using this gray material. Another important thing is that at the back side here you see two blocks. These are called as feeders, and we have again a kind of a motor here. Motor inside this feeder is squeezing first the filament and then pushing it upwards, so that extrusion will be actually carried out inside these nozzles. You see the nozzles here, there are 2 nozzles. And if you want to do extrusion, you need to have pressure. And this pressure is actually acquired with the help of the, let me move it like this. Yes, this is the feeder, and our filament is going into here. And with the help of the motor here, we also have a kind of a gear there. It's squeezing our filament and then pushing it upwards. And then it moves through this tube and goes into our nozzle. Okay, any questions, guys?
Hocam,
Yep.
nozzle'un birinde CC, diğerinde AA yazıyor. Arasındaki
Yep.
fark ne?
CC is for some special materials. You can extrude, as I mentioned, some materials having abrasive materials inside, like carbon fibers. But you cannot use the other one, AA04, for special materials. You can only use it for PLA or ABS material. Now it's just restarted. And I also have an exaggerated view of this nozzle actually. It's not exactly the nozzle I am using on this printer, but it's a nozzle, the printed version of the Prusa. This is actually the heating block. And this is our heater actually. With the help of this red block, we are heating this white box. And we have a thermocouple here. It's sensing the temperature of this block and sending this information to the controller so that it will have a kind of a closed loop there and try to keep that temperature at the predefined value. And then this is our nozzle arrangement. This is the nozzle, the cross section of the nozzle, and the filament will go through this nozzle and then extrude it, okay? And the thing is that at the top side of this nozzle, we have such a component, and you see that it has some fins around. The reason is that it tries to actually cool down the filament, which is above the nozzle. I'm sorry. We don't actually want the filament be melted around this region. We want our filament be melted right at the tip of this nozzle. Otherwise, it may close these regions and we may not be able to push it. So this is an important issue. And as I mentioned a moment ago, with the help of the feeders, we are always pushing, we are applying pressure onto this filament and trying to do the extrusion. This is a very fundamental thing. And we have a similar arrangement again in our printer beside me. Any other questions?
Hocam bir şey sorabilir miyim?
Yes.
Başka 3D printerlarda nozzle hani Z eksisi yönünde hareket ediyor. Bunun table hareket ediyor dediniz. Ne farkları oluyor ikisinin?
No difference. Fundamental operations, the fundamental manufacturing technology is the same. You may have even, for instance, this one is fixed. Actually, I don't know whether you can see, this is our hybrid system here. You may see that this is fixed. And here our table is moving in X and Y, but the head is just moving in Z direction. So we have another arrangement there. But no difference, the fundamentals are the same. So we simply generate the comments accordingly. Actually, the G-code file is important. You need to convert these motions properly. Otherwise, your part will not be able to actually not have a desired properties.
Tamam,
Any
teşekkür
other
ederim.
questions, guys? If not, then I may switch to the Cura. Yes. Do you see Cura right now?
Yes.
And now I'm going to print this figure. What is the name of this one? Anyone knowing the name of this one? totodile.
Hocam bu.
But right now, as you see, it will take about 3 hours. So we don't have 3 hours left. Maybe another issue I'm using the second extruder, second material. Here you see. And so I will now take this USB and I will install the G code into that USB and then later start the printing. Let's simplify some of these settings. I want to print it in a fast manner. So let's play with them. The layer height is right now 0.2, wall thickness 1, okay, and the top bottom are fine. I have 20 in fill and material is okay. Speed, travel, cooling, and support. I want to have a support. I want to show you the support structures, but I need to use obviously extruder 2. And for the brim, again, I want to use extruder 2. Okay, now it's slicing, but it couldn't slice. Why is that? Yes, now it's fine. So I will now save it to the removable disk. And it's already saved. And I will simply eject it and then install it onto my printer. There's a problem. But I think I can remove it. So let me see if it's exactly on the USB. Yes. Now it will first actually do some calibration kind of things. It will check whether the level of the Z is fine or not. And then it will start heating the bed. Here you see the build plate temperature is set to 60. So after this bed reaches to temperature 60, it will start increasing the temperature of the nozzle and then start the printing process. And I want to show you some issues here. Let me move this one. Yes. As you see around this part, we have more material, and this is called as brim. And since if you just purely print the toy, then you may have problems since it may not be sticking to the bed or the plate properly, and at the upcoming layers you may have problems. Once you have some forces from right or left hand side, it may be removed from the table and your printer will not be able to finish the printing. Another issue is that I'm using right now some support structures. These are here. Let me switch to this orientation. We have some little support structure here. So after the part is printed, I can simply remove that support structure and start playing with my toy. Any questions, guys? Right now it's heating, so it will not start in a second, maybe in a few minutes, it will start the printing process. If you don't have questions, then I may switch to the slides and then show you the process from time to time.
Is it using STL file format?
Yes, right now I imported an STL file into that Cura. But you may also use an OBJ file or different, some other formats, but not much. The file format you're actually importing should represent the outer surface, the surface of the part you're going to print. It shouldn't have any more information. Any other guys, questions? So let's switch to the slides. Okay, as you see, we are discussing extrusion-based systems, and we have gone through an example of it, fused flame fabrication system, but it's not just a single one. We have many extrusion-based systems. Let's have a look at an example extrusion-based system. This is from Bailia, and they have, oops, let me show you that video. Share the browser. Yes, I think, do you see the video now? They are using extrusion-based system to print, to fabricate such pasta. They have again kind of similar nozzles. They have similar software, such STL files are used, I guess. They design some special shapes, such as rolls. So the critical thing is have proper material. So they have such ingredients, and they need to have a proper combination of them. And you can obviously do some customization according to your taste. You may have one ingredient more or the other less. As you see, they also done the slicing. Yeah, this is how they do the printing. This is the extruder head, and this is the nozzle, and pasta is being extruded. But if you look at the size of their head, it's quite large, since it's not easy to fabricate or manufacture pasta. So this is a nice example of an extrusion-based additive manufacturing approach. And I will show you another one. Oops, this video is not available, not a big issue. So let's switch to the slides. And I was planning to show this one. Probably if you search for it, they may have moved the video to another maybe account. And they're again kind of printing a food dessert. It's called a strawberry jelly octopus, but the fundamentals are the same. Again, they have a special extruder head, a special syringe, and with, again, doing slicing and generating the pad, it moves over the table and prints this dessert. I'm not sure this one today, and not today these, but we can start start discussing the fundamentals of extrusion-based systems. By the way, our printer started printing process, but I'm not sure it's printing properly or not. Right now, I don't see any extruded material. I think we have a problem. The material actually didn't stick to the table. Right now it starts sticking, but the initial portions didn't stick well. I don't know whether you see it, but we have kind of a mess right now at the initial layer. This happens usually, and so the level of your table is quite important. If you have misalignment like this, you may have problems on the first layer, and this will directly affect the quality of your print. But right now it's getting better. I think in the second layer it will be much better. From time to time I will switch to this print, and you can have a look at it, how it's going, and I may answer your questions during other, let's say, shows. Any questions, guys?
Hocam başta bir fazla materyal dağıtıyor demiştiniz ya tablayı sabitleme yani üstüne daha iyi kurabilmek için.
Yep.
Onu siz mi belirliyorsunuz yoksa kuranın otomatik yaptığı bir şey mi?
You do it actually in the settings. You may not have it. It's up to you. You may just directly print the product, but it's better you have some extra so that the sticking will be much better. But it's not a must.
Teşekkürler hocam.
Right now, the bed is quite, the temperature is quite high. I cannot put my fingers maybe more than a second. And I think it's getting better, so we can once again switch to the slides. So we said that the extrusion-based systems are highly popular, and what we do in these extrusion-based systems, the material should be in a semi-solid state, or sometimes it might be completely liquid, but if it's completely liquid, then controlling of the extrusion is quite difficult. So we prefer to have it in semi-solid state. And then what we do, we need to apply some pressure, as in the case of FDM, we need to apply pressure from backside and let the material actually go out through that nozzle. So if the pressure you are applying is constant, then we can make sure that you have a constant flow of material. Another thing, obviously, you should have enough material at the backside. If you run out of material, then your flow will not be constant. Another thing is that if you have material, if the pressure is constant, and if your speed of nozzle head or the speed of the head is constant, then the cross section will always be constant. But if you increase speed, let's say in a very short amount of time, then the thickness, the cross section will be decreased. So this is actually another thing we discussed. After you extrude the material, it should be solidified as soon as possible. And during the solidification, it should be stick to the bed against the first layer, or it should be stick to the previous layer. So during actually these motions, these extrusion-based systems, we should have some kind of machines which has a capability of scanning the horizontal plane. Like in our printer, here it should scan the whole plane, and then it should be able to start the flow and restart it again. Since sometimes while going from one point, you may need to stop and then go to another point in a faster manner. So if your printer doesn't have such capabilities, then you will have some extra material all around your part. And then obviously, since we are doing this fabrication layer by layer, your printer should be able to, your system should be able to moving upwards and downwards. We have two primary approaches for increasing the temperature or changing the state of your material. We can simply control the temperature so that the material will be melted completely, or it will be in semi-solid state, or some complicated systems, some complicated extrusion-based systems. You may have chemical reactions by adding some extra chemicals into your chamber. You may start some reactions, and your material might be melted first, and then it may even be solidified with the help of your special chemicals. So what are the basic principles in extrusion-based systems? Obviously, we need to be able to load the material. Otherwise, you will not be able to start the extrusion. Another thing, you should be able to liquefy the material, change the state of it, make it a semi-solid material or totally a liquid material. And then you need to apply pressure continuously so that the material will be moving through the nozzle. And with the help of these, we can do the extrusion. And obviously, another thing is that your controlling should be as fine as possible. So if you have If you do not control it properly, then you'll not be able to obtain the desired shape. So controlling is highly important, especially on the X and Y plane, since they determine the quality of your extrusion. Another issue, bonding, the bonding of your material to the table, to the base plate, or bonding your material to the previous layer. We should have a proper connection between the layers, or a proper connection between the first layer and the base plate. Otherwise, you'll not be able to go on with the upcoming slides. Another issue, since we are not actually doing this printing operation on a bed, we may sometimes need to have special support structures. For instance, if you look at this shape here, this bunny, let me stop sharing. You see that bunny here? Since we have shallow angles here in the ear side, we need to have support structures so that once the material is extruded around here, it will not fall on ground. So these are must actually for such extrusion-based systems. And they don't need to actually start from the base. If you look at here, this support structure starts from the body of the bunny. So we may start constructing or start building our support structures anywhere on our plate or anywhere on the body. And later, after the print is over, we can simply apply some pressure, or by using some mechanical components, you can remove these support structures. So now we will go into discussing these stages one by one. But before that, if you have questions, I can answer some of these. And your friend actually sent you a link. If you are interested, you may have a look at this chocolate printer. There are such printers available. You may print some special chocolates at home for your loved ones. No questions? Okay, let's have a look at the first principle, the loading of material, the first part of our extrusion process. So you need to have a kind of a chamber for the extrusion. And in our case, you may assume that the chamber is actually this region, the region upside of our nozzle. It should be obviously preloaded with material. If you consider, for instance, the pasta case, pasta printer, we need to have a chamber actually loaded with some pasta material, pasta ingredients. And obviously another thing is that you need to have a continuous supply of material. In our case, we have a spool of material backside, so we can assume that they are continuous supply of this material. Another thing, if you are using liquid material, not actually semi-solid or solid material, then you should have some pumping equipment so that your liquid material will easily pump out of the nozzle and you will solidify them right after extrusion. But for the other ones, we use usually powders, some other small materials and filaments. You can see here some examples of granules. We don't need to use actually some filaments. You may start directly with such granules, but the thing is that you need to increase their temperature so that they will be joined together and then you have a continuous supply of material. Right now, as you see, we have discrete particles, so which means that it's not satisfied, so you need to satisfy this condition underneath this region. With the help of a screw here, as you see, this screw will be pushing all these granules into a channel, and then probably in that channel, they will be using some heaters. The temperature of the channel will be increased, and these materials will be melted. And to the end of that chamber, probably they will have a nozzle, and that material will be extruded through that nozzle. So what about filaments? How do we actually obtain such filaments? Anyone planning to answer, guys?
Extrusion maybe.
Yes, again, we will be using the fundamentals of extrusion. By using extrusion method, we will first obtain the filaments and then use that filament in our printer once again to do another extrusion. So we can say that it's a two-step extrusion process. We do it first for obtaining the filaments and then do it for obtaining the parts. Now I want to show you a new, let's say, equipment. We are trying to purchase a one for our department. This is actually producing filaments by using some granules or some recycled material. Here we have the example now. I will share the screen with you in a moment. Okay, this is actually, let's run it. They have different palettes. It may have different various colors as you see. This is their system. Obviously, they have some settings. Settings for probably the controller. These are the PID parameters as you see. P0, I500, P0 right now. And the speed for extrusion. And they also need to have a parameter for the output diameter. Since this is highly important, we need to have a continuous, the exact diameter in this extrusion process. And I forgot to mention that Ultimaker printers are using filaments having diameters of 2.85, but most of other desktop printers are using diameters of 1.75. It's an empty spool as you see. This is a screw they have, so the extrusion, the main extrusion process will be done with the help of these screws. The good thing about this system is that you may add not just the granules, you may have some extra like carbon fibers or different materials, maybe wood or different materials, and try to do some research on these new materials. So this is the extruded filaments. And obviously the temperature is high, so you need to somehow control it properly and try to solidify it as soon as possible. So you see the fresh filaments here. Now your filament is ready. You can simply plug it into your Ultimaker and start printing. And this will be obviously a customized filament. As written here, it's a custom filament, which is actually satisfying your special requirements. Yes. Any questions, guys, regarding this approach?
Hocam farklı malzemeleri karıştırınca homojen bir şekilde nasıl geçiyor filamente?
Obviously, it will not be 100% homogeneous, but you may do some maybe initial mixing first and then put it into that chamber and try to increase the level of homogeneity. But obviously, if you simply pour one material first and then the other, it will not be homogeneous.
Bir de şeyi soracaktım. Bu makarayı ilk nasıl takıyorlar ki bu dolanıyor etrafına?
I don't know these details, but probably you may do it manually, I guess. Since if you look at, I think you have a printer, so if you look at the initial regions of your spool, They are usually stick to a kind of an place. So probably you may need to do it manually. So it is difficult to do it in an automated manner, I guess. Any other questions?
Hocam ben bu cihazın şeyini izlemiştim, review'unu. Manuel olarak yapıyorlar.
Okay, thank you. Then we can continue. Yes. This is the second step of the extrusion-based systems, liquefaction. So you see a similar approach here. They have a kind of a chamber or an installation very similar to, this one. They have a chamber here. They have feeders. This is their filaments with the help of rolling system. At the beginning of the lecture, I showed you that at the back side of the printer, we have a pinch roller feed system. We have a kind of a gear there, and that gear is actually skewing the filament, and by rotating that motor, you are pushing this filament forwards. And with the help of that pressure, and with the help of the increased temperatures around here, you'll be able to extrude that semi-solid material. And that's a very simple illustration. The platform is obviously moving in Z direction, and with the help of our head moving on the XY plane, we can obtain any layer. Yes, as I said, it might be liquid or semi-solid. If it's a liquid one, then it's better to use some much professional systems like special shrink pumps or piezoelectric systems, since otherwise you may not be able to control the amount of liquid being extruded through that nozzle. As the thing actually mentioned a lot, we need to have solidification right after your material is extruded through this nozzle. So for that purpose, I said that we have some fans around, and you may now see that the layers, actually many layers are already printed, and it's about right now 1 centimeter height. So I think we may give a break right now, and I'll keep it as open so that if you are interested, you may continue watching this printing process. Maybe I may switch the position, have a better view. Okay, let's have a break, and after 10 minutes, we will continue with the slides. I will not be here, so if you have questions, please ask it at the beginning of the lecture.